Okay, today we're going to be talking about accuracy and precision. These are two extremely important terms to know, so make sure that you are taking log of what the difference between the two are, because we are going to be kind of testing this as far as what we're doing with measurements and how we are handling those in our chemistry class. You can see from this picture that there are different levels of increasing accuracy and precision. Obviously, as both of them increase, you've got the top right hand corner, and then as they are both very small, accuracy and precision, very poor, that would be the bottom left hand corner. And then on the top left and the bottom right, you have just things that are accurate and then just things that are precise. So we're going to get into the definitions of those now. Every measurement we're making is a comparison of how much we are measuring with some kind of measurement. Depends on what we're given to figure out what units we're using. Time would be seconds, or distance or length would be centimeters. And when we are making those measurements and comparing them, we are figuring out if they are accurate and precise. So accuracy and precision are those two words that we are going to be using when we are looking at measurements. For instance, the standard for measuring mass is the kilogram. So we will be using that throughout our course to be able to measure mass. What are some other standards for measurement? We have distance, which is a form of measurement. What do we end up measuring that with? We have a ruler there. You can see that it can be done in inches. That's part of the English system. Centimeters is a part of the metric system. The most basic form of measurement for distance is the meter, and we use the meter and all forms of the meter to be able to measure that. For time is universal. So no matter if it's the English or the metric system, time is always going to be measured in the most basic unit, which is seconds. And for volume, specifically in chemistry, it is the cubic centimeter, and that can also be converted into the milliliter. So that is also a unit that we use to measure volume. So what's the difference between accuracy and precision? We're going to figure that out now with our definitions. Accuracy refers to how close a measurement is to the true or accepted value of that quantity. So depending on what you're trying to achieve, what is the true value? For instance, if we're looking at grades, the true value for a grade is going to be a 100. That's what everybody's trying to achieve. And when you're looking at bullseyes, which is down there on the bottom, or targets, a bullseye would be the accurate or the true or accepted value for playing darts. So you're trying to hit the bullseye. It says the number 2.0 is more accurate than 2 because it is measured to one more decimal place. 2.00 is even more accurate, being measured to 2 decimal places. Every decimal place added to a value adds a degree of certainty. So the farther that you go with your decimal, the more accurate your measurement is. Now that doesn't mean if I'm going to add zeros and zeros and zeros, then it's just going to happen. It's what I'm measuring. I can't just make up numbers and have it be accurate. It has to be actually what we're measuring. So accuracy is the right answer, what you're trying to achieve, the absolute goal, true or accepted value. So here's an example. We have two people measuring a textbook, and we need to figure out who is the most accurate and has the true length of 17.0 centimeters. Susan has 4 measurements: 17.0, 16.0, 18.0, and 15.0. Amy has 15.5, 15.0, 15.2, and 15.3. Now, if we're looking at accuracy for this measurement, we are looking to try to get as close to 17 as possible, as much as possible. So the one that actually gets to 17 or close to 17 would be Susan compared to Amy. So Susan would have the more accurate measurement here. Amy has generally the same numbers, but they are not close to 17, so she is therefore not an accurate measurer. When we're looking at lab equipment or equipment to measure, we have to compare and see what is going to be the best equipment for us to be able to measure with accuracy and precision. So if we're looking at a ruler, we have centimeters on the top and millimeters on the bottom. Centimeters are going to be somewhat accurate, and then millimeters are going to be very accurate. Notice that the millimeter side of the ruler has a lot of different lines, whereas the centimeters has a very large gap between each of the numbers. That's why it's going to be less accurate than the millimeters. On the bottom left, or on the bottom right, I'm sorry, we have a beaker versus a graduated cylinder. A beaker only has general numbers on the side of it, and it does not show a lot of little lines to be able to figure out exactly how much we have. So if it's sitting between 200 milliliters and 300 milliliters, we're guesstimating exactly how much liquid we have in that beaker. So that one is going to be somewhat accurate, whereas the graduated cylinder, they have many, many lines in between each of the major numbers of measurement. So therefore, when we are measuring any kind of liquid in a graduated cylinder, that one will be considered accurate and more accurate than a beaker. So the most accurate for measuring liquid, the most accurate piece of equipment would be a graduated cylinder. So what is the difference between them? We figured out that accuracy was how close you are to a true or accepted value. Precision refers how close you are to each other. So say that you take multiple measurements, which usually we do, and they are all around the same area. That would be precision. If you shot an arrow at a target and all of the arrows were in the outer ring close to each other, you are precise, but you are not accurate. If you were accurate, you would be close to the bullseye in the middle. So notice all of these arrows on the outside are close together. That would be precision. So precision is consistency, whereas accuracy is the right answer. Here's another example of the measurements with Susan and Amy. If they're measuring and we're looking at precision specifically, we're not necessarily trying to get the true or accepted value. We're trying to see how close our measurements are together. Amy would be the one that had the most precise measurements. All of her numbers are in 15, and the decimals after the 15 are very close together, so she has the precise measurements out of Susan and Amy. On this slide, we have two targets. One of the targets has arrows all together and in the middle. That's the one on the left. And the one on the right has arrows all together but not in the middle. So if we were looking at these, the one on the left would have a high accuracy and a high precision. They are all towards the middle, which is what we are trying to get on a target. They are all generally in the same area. That is precision. The one on the right is going to have a low accuracy and a high precision because they are together in the same general area, but they are not in the middle, which is the true or accepted value, which is what we are looking for. We have three targets with 3 arrows each to shoot. So if we shoot those arrows, how do they compare to each other, and what kind of accuracy and precision do we have? The target on the very left has both accuracy and precision because they are all together and they are towards the middle of the target where the bullseye is. The second one does not have accuracy, but it does have precision because they are all in the same general area close to each other, but they are not close to the true or accepted value, which is the middle. The one on the right has low precision because they are spaced out, and it has low accuracy because they are all over the place. They're nowhere close to the middle. So those would be neither accurate nor precise. If we were given these 3 targets and you had to figure out if it is accurate, precise, or both, what would you answer for each of these? On the left, we have 5 arrows and they are all over the place. This one would have low accuracy and low precision. In the middle, we have 4 arrows and they are generally close to each other at the top of our target. This one would be a low accuracy as it's not close to the middle, and a high precision. On the right hand side, we have 4 arrows. They are generally close together and in the middle, so this is going to be a high accuracy, high precision target. Here are some more visual examples. On the left, accurate but not precise. In the middle, precise but not accurate. And on the right, we have accurate and precise. And then if we are referencing a sport, specifically golf could be an easy one to use for accuracy and precision. The left-hand side, we have an example of high precision but low accuracy as they are nowhere near the actual hole. On the right-hand side, we have an example of high accuracy and low precision, whereas they're close to the hole, but they are not really close together. This is going to be an example of how we can know accuracy and precision.